Hello dear students, now I am continuing functions, chapter 2, continuing functions. So graph of some functions there. So we know about identity function, constant function, polynomial function, rational functions, and there are also three functions are very important. So modulus function, modulus function, modulus function, frequently used in everywhere. Okay, so modulus function is given like this: fx equals to mod x. Modulus function is absolute value, absolute value of this means always gives positive value. For this function, domain is complete real number. Domain is complete real number. Suppose a real number, we know real number how? This is 0, this is minus infinity to plus infinity. Okay? So negative side, positive side. There are negative values, there are positive values. X belongs to R, real number. Okay, so we can divide this number x less than 0, x less than 0, x greater than 0, and this is x equals to 0 here. And this part x less than 0, x greater than 0. So if x less than 0, that is negative value, any value negative. To make it positive, we have to multiply it by minus sign. So x is negative, so positive. Yes. And if x is greater than 0, already positive. If x equal 0, x. So this is the definition, breaking of modulus. This is mod x, breaking of this. Domain is complete real number. And range, what will be the range? Because it gives always positive value, set of all non-negative real numbers. Non-negative means positive real numbers. Its graphs like this. X-axis and here y-axis. This is origin. So for positive value, y equals to x. Y equals to x. For positive value, from here to this. What? Y equals to x for positive value. So graph will be like this. Y equals to x. Means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and so on. And for negative value, y equals to minus x. Y equals to minus x is what? For negative value means here. As we give negative value, then for minus 1, y is positive. Because y is always positive. Here, for negative value, we will get also point like this: minus 1, 1, minus 2, 2, minus 3, 3, upper side, the value of y. So, graph is like this. Clear? This is y equals to minus x. Y equals to minus x. So, this is the graph of modulus function, V shape. Okay, from 0 to this mod x. Clear? Graph of modulus function. And mod can be break by using this condition. Clear? Suppose we are having mod x minus 2, fx equals to. For example, fx equal to mod x minus 2. Then how can we break this modulus? If this is negative, then minus sign is in front. So minus of x minus 2 if x minus 2 is less than 0. In place of x minus 2, x, there is x minus 2. So, and if x minus 2 is greater than equal 0, then x minus 2. So, this is equals to what? Minus x plus 2. So, minus x plus 2 if here x is less than 2. X is less than 2. And here x minus 2 if x is greater than equal to 2. This is the breaking of this modulus. So by using this definition we can break modulus in two parts. Clear? So very important functions. So remember it. How can we break modulus in interval? Okay, and graph of modulus function is this. Clear? Next function is signum function. Signum function means for sign. It is used in higher classes. Okay. So signum function we can define like signum function. Signum function. Clear? Signum function. Okay, this is defined as in breaking mode. It is also defined as like this: f from R to R such that fx equals to, means domain is set of real number and range is subset of this, that is in breaking part 1, 0, minus 1 if x is greater than 0, if x equal 0, if x less than 0. Clear? X less than 0. This is what signum function. Okay, its graph we can show. X greater than 0, x less than 0, x equal 0, that is total real number. So, total real number is this. X axis, this is total real number, minus infinity to plus infinity, that is 0. So, vertical line is this, y dash, this is y. Okay, this is 0 portion. Now, x greater than 0, that means here, not equal 0, greater than 0. Greater than 0, that is the value of y. Fx means what? Y. So, y equals to what? Fx. So, y equals to 1. The value of y is 1 for x greater than 0. That is, in here, the value of y is always 1. So, suppose this is 1. Suppose this is 1 distance. So, here, not equal 0, except 0. So, this line will be y equals to 1. Y equals to 1. Always y equals to 1 for x greater than 0. And at 0, x equal to 0, then the value of y is 0. That is this bold. And this is here hollow. Clear? Similarly, y equals to minus 1, x less than 0, x less than 0, x less than 0 is negative side is here. So, minus 1. So, here, suppose minus 1. Here, minus 1. Not at 0. Minus 1. So, here, distance minus 1, value of y minus 1. So this is showing like this. Y equals to minus 1 and negative side. So this is the graph. Y equals to 1 here, y equals to minus 1 here, and at x equal to 0, this is dot. So this two lines are graph of signum function. Clear? It is useful in higher classes. So just know what is signum function. Signum function is this. Its domain is complete real number and range is what? Value of y 1, 0, minus 1, that is minus 1, 0 and 1. Set of these three element is range. And domain what? Set of the real number. Okay. So this is signum function, graph of signum function. Okay. Now greatest integer function. That is important function, useful for this class and so for 12th class and also for higher classes. Greatest integer function. Okay. So note down this function, very important function. Greatest integer function and defined by this defined by this. Clear? So here greatest integer function domain is what? R to R. Function defined from R to R such that fx equals to this denoted by this. This is equals to what? We cannot write total value, but make this denotes greatest integer less than or equal to x. Okay, greatest integers less than or equal to x in an interval. Okay, or greatest integer just less than x. You can see integers. Okay, so greatest integer less than or equals to x. How? Suppose domain is complete real number, so this is minus infinity to plus infinity, real line, this is x to x dash is 0. Now vertical line is this, y axis, y dash, y, this is origin. Now it gives just like this. Suppose if x belongs to means from 0 to 1, we take 0 but not 1, 0 take. Okay, in this interval that is x less than 1 greater than equal 0. In this interval number 0 is integer, and 0.1, 0.2, 0.5, 0.6, 0.7, the value of x and greatest integer less than or equal to, suppose we take from here 0.5, then less than, then integers on left hand side 0, -1, -2, -3, these are infinite integers, but greatest integer what? 0, which is less than or equals to 0.5, less than or equal to 0.5. So if 0.5 then also 0, if 0.6 then also 0, if 0.23 also 0, if 0 then also 0, less than or equal to. Okay. So in this interval the value of this is equals to what? 0. Clear? Now suppose 1 to 2, now taking 1 just less than will, here taking just like this, 1 less than equal x less than 2, then in this interval just like this 0, 1 and 1.5, 1.2, 1.3 just less than or equal to integer, greatest integer 1, 1. So in this interval the value is 1. Similarly 2 is less than equal x less than 3, and here also we can write what? -1 is less than equal x less than 0, -2 is less than equal 1 is less than -1, -1, -2. Okay, so this type of values we can get. Okay, so graph will be like this: -1, -2, -3, +3. Here value of the function is 0. In this interval 0. In this interval, that is in this interval 1. So in this interval including 1. So if this is 1, then 1, 2, 3, 1, 2, 3, negative value. Here negative value. So graph in this interval 1, value of y is 1. Here 2, here -1. So -1. So this here -2, here -3. Similarly here like just like this. Clear? 1, 2, 3. So 2 and then just like this we can draw the graph. Okay, so this is the greatest integer function. Clear? So graph of greatest integer function is this. How can we interpret the value of greatest integer function? Suppose we are giving just like this 3.5, then this is equals to what? 3. Suppose 7.9, this is equals to what? 7. Suppose -0.9, this is equals to what? -1, because -0.9 is lying here. So value is minus 1. 7.9 is lying what? In which interval? 7 to 8. This is 3 to 4. So this is equals to 3. Just less than or equal to integer. Just less than or equal to integer. Just less than or equal to integer minus 1. Okay, so the value of this is this. So this is greatest integer function, and graph of this function is also like step function, and this is the finding method, the finding value of greatest integer is this. Okay, so greatest integer less than or equals to x. Remember it. Okay, very important function. Okay, now we will solve questions from miscellaneous exercise of chapter 2, one by one. So remember, at least solution of at least 3 questions you have to send me. Solution of at least 3 questions you have to send me for your attendance on the same day, today, that means. Okay, 3 questions, at least 3 questions. Solution of 3 questions. So here, first questions is at least 3 answer of 3 questions you have to send me for your attendance. So first, so let us solve miscellaneous exercise of chapter 2. First question. The relation f is defined by relation g is defined by, so that f is function, g is not function. Okay, so here solution 1. Solution 1. Here given question 1, given what? Function f is given just like this. F is given x square 3x, x square and 3x, and here 0 less than equal x less than equal 3 and 3 less than equal x less than equal 10, just like this. Okay, and g is given x square 3x, x square 3x, 0 less than equal x less than equal 2 and 2 less than equal x less than equal 10. This is the definition according to question. F is defined as like this, G is defined as like this, means its domain 0 to 10 real number. But this interval 0 to 10 is distributed in 2 parts, 0 to 3, 3 to 10. Here equal 3 also gives x square, for x equal 3 also gives by 3x. This is the relation, and this is also a relation. Also 0 to 10 is divided at the point 2, here at the point 3, here at the point 2, less than equal to, less than equal to. So also for 2 equals to x square, for 2 equals to 3x. So these are 2 relations according to questions. We have to prove that f is a function and g is not a function. Clear? Given this and this, given relations, this and this. In first relation, here we know that relation will be a function if all the elements of the domain of the relation are connected to unique element to the codomain. That is first, because relations are set of order pairs. So first elements are different and also their connected elements should be unique, not different. Clear? So here for in first relation for x equals to 3, for x equals to 3, we see that fx equals to f means fx equals to x equals 3 x square means f3 equals to 3 square equals to 9. And also for x equals to 3 and also for f3 equals to 3 into 3 equals to 9 from this both place. That is 3 is connected to 9, 3 is connected to 9, unique element. And also for x lies between 0 to 3, only 3, not for fx equals to what? X square. And 3 less than x less than equal 10, fx equals to 3x. This is unique element for this part. Here 3 is not involved. Here 3 is also not involved. For this part x square, for this part 3x. And for 3, here both in both place, for we are calculating from both place 9. That is, so we get that elements of domain of relation F connected to unique element. Relation F are connected to unique element. Implies F is a function. Clear? F is a function. Okay. Now take this now take function relation G. Oh, in relation G there is also bifurcation at 2. 2 is also including here and 2 is also including here. So for x equals to 2, gx equals to what is the value of gx from both places. In second relation for x equals to 2, x equals to 2, gx equals to x square implies g2 equals to 2 square equals to 4. Clear? Also gx equals to 3x equals to, so g2 equals to 3 into 2 equals to 6 equal to 3x equal to x square. So we see that 2 is connected to two different elements. That is in the order pair first elements are same as 2 and second elements are different 4 and 6. So that is not function. Okay. So we see that first element of order pairs of relation G are same as 2, but second element are different as 4 and 6, implies G is not a function, that is 2 is not connected to unique element, that is 2 is not connected to the unique element. Okay, so G is not a function. So this was the proof of f is a function and G is not a function. Clear? Then, so this was the solution of question first of miscellaneous exercise. Okay. Now take question second. Remember, you have to send at least solution of at least 3 questions to me as a PDF file for your attendance. Rename also PDF as your short name. Okay. Now take question second. Second question is very simple. You can do it. Here fx equals to x square. Here given what? Fx is equals to x square and find f 1.1 minus f1 upon f 1.1 minus 1. Okay, find this. Clear? F 1.1 minus f1 upon f 1.1. This we have to find. Clear? Very simple. So 1.1 minus 1.1 and f 1.1 minus f1. This is different given definition. From definition of function, we get what? F 1.1 minus f1 upon 1.1 minus 1 is equals to what? F 1.1 means in place of x 1.1. So x means x square. So 1.1 square minus f1 means 1 square upon 1.1 minus 1 means 0.1. So this is equals to what? 1.1 but the 121 1.21. So 1.21 minus 1 upon 0.1 means 0.21 upon 0.1. That is what? 2.1. 2.1. Clear? Denominator, in denominator there will be 2 0 and there will be 1 0 1 0. Cancel 1 0 1 0. The 2.1. 2.1 is the value. Very simple questions. Okay. So only this question was based on the finding value of function. Clear? So very simple questions. Now take question third. Question third. Third question is given as what? Find the domain of the function x square plus 2x plus 1 given the function is x square plus 2x plus 1 upon what? X square minus 8x plus 12. X square minus 8x plus 12. This is given function. Clear? Given fx equal to this. And we have to find domain of this function. Domain means what? Domain contains all those values of x for which fx is defined. Okay? Domain contains all those elements of x for which function is defined. So here domain contains all values of x for which fx is defined. Here for existence of fx means fx should be defined. But if denominator is equals to 0, then it is not defined. So for existence of fx, x square minus 8x plus 12 should not equals to 0. Should not equals to 0. Should not equals to 0 for example. That is if x square minus 8x plus 12 equals to, that is, you can factorize it. Factorize this x square minus 12, 6 2 minus 2x minus 6x, 6 into 2, 12, so plus 12, so you can write like this, minus 8x, 12x square, so plus 12, that is x common, x minus 2, minus 6 common, x minus 2, that is x minus 2, x minus 6, that is x is not equals to 2 and not equals to 6. This should not equals to 0. If x equals to 2, this is 0. If x equals to 6, this is 0. So x is not equals to 2 and not equals to 6. Clear? So except 2 and 6, fx is defined. Implies fx is defined for all real values of x, except x equals to 2 and 6. X equals to 2 and 6. That is, so domain of f is equals to what? Set of real number minus 2 comma 6. Okay, this is our answer. Domain of f, set of real number minus 2 and 6, except 2 and 6. This is domain. This is defined. Function is defined. So domain is this. Okay. So for finding domain of a function, we have to see for which value function is defined. If there is denominator, then the values of x for which denominator is 0, we have to delete from set of real numbers. Then this is this. R is this. You see, delete means minus remove. that elements from the set of real numbers. So this is the domain of questions 3. Okay. Now question to find the domain and range of the real function f defined by f is equal to root x minus 1. Domain and range. Questions 4. Okay. We have to solve question 4. Here we have to find the domain and range. Given function is fx equals to root over x minus 1. Okay, and root over x minus 1, clear? We have to find domain and range. Here we know under square root, for real value under a square root, there should not be negative values. For getting real values for real function, so for real function, so for real value x minus quantity under square root should not be less than. Here for real values of fx x minus 1 should not be negative. X minus 1, that is quantity under square root, x minus 1 should not be negative. That is x minus 1 should be greater than 0 for real values of x, greater than equal to 0. Should not be negative, it is less than. So greater than equal to 0 implies x is greater than equal to 1, implies x belongs to 1 to infinity. So this is domain. X is greater than equal to 1. Therefore domain f is equals to 1 infinity. Clear? This is the domain. And for finding range, here for x belongs to the domain. Okay, now domain contains 1 to infinity, that is s greater than equal to 1. Now for x belongs to 1 infinity, that is x greater than 1, we have x minus 1 is greater than equal to 0, implies root of x minus, this is greater than equal to 0, that is fx y equals to fx is greater than equal to 0, that is y belongs to 0 to infinity. Okay, therefore range f is 0 to infinity. Clear? So this is the range of the function fx equal to root x minus 1. Okay. Now take question 5. Remember, you have to reply 3 questions, the solution of 3 questions. Okay, now take question 5. Here, question 5 is given. Find the domain and range of the real function defined by f(x) equal to mod x minus 1. Here given real function mod x minus 1. Real function mod x minus 1. We have to find domain and range. Clear? Domain and range. We know that if we give any real number to x here, then we can get some value. Because modulus function is defined for all real values. Okay, so its domain is here. Function is modulus function. As mod x minus 1, so its domain is equals to set of real, total set of real numbers. We can give any real number to x, then you can get some value. And we know that a modulus function gives always positive values. So f(x) is greater than equal to 0, implies range f is equals to 0 to infinity. So range f equals to 0 infinity, means including 0 infinity. So for question 5, mod x minus modulus function, so domain is a set of real numbers and its range, modulus function always gives positive values. Function gives always positive values, though greater than equal to 0. So 0 infinity. So these are the domain and range of this questions 5. So today I have already discussed about 3 functions and their graphs, and also 5 questions of miscellaneous exercise. So you have to reply me by making PDF file of solutions of at least 3 questions today. Okay, so that will be your attendance for this class. Okay, so remember it and send me file. Okay.